Okay, we are here on day 30. Is it at the bottom? My kitchen table. Day 30. Okay, page 5 of 11. I'm going right to the math windows. Okay, if you're not there, you can pause. You can always pause. Use a lot of pausing to work problems on your own, and then watch the solutions. But use the pause a lot when you're watching my videos. Okay. Okay, math windows. 5 2/3. That's a mixed fraction. Remember, mixed fraction as a whole number and a fraction together. Divided by 1 1/2. Now, if this was 5 divided by 1, the answer would be 5. But we're dividing by a bigger number, 1 1/2. So the answer is probably going to be about 3. 3 times 1 1/2 is 4 1/2. So the answer has to be a little bit bigger than 3. Okay? 4 times 1 1/2, by the way, is 4 times 1 is 4, and 4 halves make another 2. That would be 6. So 4 is too big, 3 is too small, so it's between 3 and 4. Okay, how do we do it? Well, the way you solve fractions, by the way, on your calculator, there is a way to do it, but I don't have your calculator with me for this. But in class, or maybe when we actually do fractions, I'll show you on your calculators a function you can use. My calculator does not have that function for how to work with fractions on a calculator, because remember, you will have a calculator on your test. Okay, how did we used to do this? 5 2/3 divided by 1 1/2. Well, it's hard to do when it's a mixed number like this, so I'm going to change it to an improper fraction. What does that mean? Well, you remember that means that we're going to take I always think of pizzas. We're talking about thirds. 5 2/3. If you have 5 pizzas and each of them is divided into thirds, there's 3 thirds in each one. So a pizza would look like this, maybe. 3 pieces, thirds. And you want 5 of these, so 5 of these pizzas would give you 5 times 3, 15 pieces. Plus 2 more left over, that's 17 thirds. Okay? Divided by 1 1/2. Well, one pizza has 2 halves, plus 1 more half makes 3. 2 times 1 is 2, and 1 more is 3 halves. 17 thirds divided by 3 halves. Now, how do we do division? You do division by changing it to multiplication. You keep the 17 thirds, but we take the reciprocal and we're going to multiply times, not 3 halves, but we turn it upside down, 2 thirds. 17 halves times 2 thirds. Now we can multiply fractions easier. 2 times 17 is 34. 3 times 3 is 9. 34 ninths. Now, that's a good answer, but they might want it written as a mixed number. So what do? Well, this time there's 9 pieces in each pizza. So how many pizzas can we make? How many whole pizzas? Well, you divide 9 into 34, goes 3 times. 3 times 9 is 27. So 3 pizzas make 27. Now we need 34 minus 27. There's 7 pieces left over. That's 7 ninths. 9 goes into 34. 3 times 9 is 27. There's 7 left over, 7 ninths. 3 7 ninths. That would be your answer. Okay. Round 1,543,976 to the nearest thousand. Where's the thousands? Well, that's the ones. There's 6 ones. There's 7 tens. There's 9 hundreds. And there's 3 thousands. So our answer is going to be 543,000, or it's going to be 1,544,000. 1,000. We want to round it to the nearest thousands. This is the thousands place. Is it closer to 1,543,000 or 1,544,000? Well, you look at the next number after the 3, the hundreds place. There's 9 hundreds. 9 is a big number, so you round up. Anything 5 or bigger, we round up. That means we're going to go to 1,544,000. It's closer to this one. That would be the right answer. Got it? When you round to the thousands, everything else is zeros. What is this, a division problem? 10,760 divided by 20? Well, you could do that on your calculator. We used to have to do this by hand. You don't have to do it by hand. If you were doing it by hand, I'd put a 20 there, and I'd put 10,760 here. First thing I do, I see there's a 0 and a 0, so I'm going to get rid of the zeros. I'm dividing both by 10. So now I'm going to do 2 into this. 2 doesn't go into 1, 2 goes into 10, 5. Nothing left over, so 2 goes into 7. 3 times 2 is 6, so there's 1 left over. I put the 1 in front of the 6, 16. 2 into 16 goes 8, and we got rid of the 0, so the answer is 538. 538. But you can do that with your calculator. You're not going to have problems like that on the test because you have a calculator that would give you something easy to do on a calculator. Okay, using the following information, how much would a large pizza with 3 toppings cost? A large pizza with 3 toppings. A large pizza with 1 topping costs $14. So we know we're paying $14, right? And we get 1 topping included already. But we want 3 toppings. We already got 1 topping. How many more toppings are we getting? If we got 1, we're getting 2 more toppings because we want 3 toppings. $2 for each additional topping. And we're getting 2 more toppings. 2 times 2 is 4. So we pay $14 for the pizza with 1 topping and $4 for the other 2 toppings. All together, is that what you got? That one, I hope you paused and did that one by yourself. Pretty simple. Should be doing those by yourself. Okay, so we're moving on to our lesson. In day 30, we're solving simple equations. Simple equations. And so you can read this over if you like. Solving multi-step equations. Okay, basically you're starting with an equation and you want to end up where it says x equals. Well, x equals. That's where you want to end up. So we want to get rid of everything except the x. How do we do that? Okay, you can read through this. It might help you understand things better. I'm going to go right to the problems. Okay, right to the problems. And I'm going to need paper to solve these because they didn't leave us much room here. Okay, hold on. I'll get a piece of paper, a blank piece of paper. Don't go away. Find me some paper. I will be back shortly. Still with me? Wait, that's not paper. What the heck? That isn't paper either. I'm coming. Don't worry. I'm still coming. This is called being prepared, or not being prepared, rather. Okay, I'm back. First one, 7x equals 63. 7x equals 63. Now, I want to get to where it says x equals. Okay, now, 7x equals 63. Well, we want to get to x equals 3. We want 1x. Remember, if it says x, that means 1x. So we want the 7 to turn into a 1. How do we get the 7 to turn to 1? I could subtract 6x. If I get 7x and subtract 6x, that'll give me x. But then I'm going to get 6x on the other side, because whatever you do to one side, you have to do to the other. And I'll get 63 minus 6x. So I'll have an x, but I'll have x's over here. I don't want to do it that way. Another way to get to 1 is if I divide. This means 7 times x. So if I divide by 7, 7 divided by 7 is 1. But if you're going to divide that side by 7, you must also divide this side by 7. So you get x equals what? 63 divided by 7. You could put that in your calculator. What would you get? 9. X equals 9. So when you have something like this, 7x equals 63, all you do is divide both sides by 7. In a way, you're moving the 7 to this side, and you're getting x equals 63. You're getting x equals 63 divided by 7. I don't know if you can see that. Well, x equals 63 divided by 7. Okay, let's try this one. Number 2. 23 plus m equals 51. Okay? Now, I want to end up with m. Remember, I'm trying to get to m equals. So I want to get rid of this 23. Well, I got 23 plus m equals 51. I can just subtract 23 from both sides. That would give me m equals 51, but you have to subtract 23. You subtract it here, it disappears. But you have to subtract it there. In a way, you're moving the 23 to the other side, but when you take plus 23 and move it to the other side, it becomes minus 23. It becomes the opposite. M equals, if you put that in your calculator, you get 28. M equals 28. Okay, number 3. Number 3 has a negative number. Okay, negative 13 equals y minus 12. Well, this time I got y on this side of the equation, so I'm going to leave it there. I want to get rid of this minus 12. How do you get rid of minus 12? You add 12 to both sides. So then I get minus 13 plus 12 is equal to y minus 12 plus 12 is 0. So just y. See, in a way, you move the 12 to this side, but since it was takeaway here, it becomes plus over on this side. It always changes. It becomes the opposite when you move it to the other side. Okay, negative and positive. When you have a negative and a positive added together, you subtract the numbers. 13 minus 12 is 1. And which is bigger, the 12 or the 13? 13 is bigger, so we take the minus sign. Y is equal to minus 1. Okay, try number 4 while I'm writing it out. Then you can pause me if you're not done. Okay, number 4 says, man, I'm having trouble reading this. I could make it bigger like this. Okay, number 4 says x over 4 is equal to minus 16. X over 4, which means x divided by 4 is equal to minus 16. Okay? Now, this time we're dividing by 4. How can we get rid of that dividing by 4? We're going to multiply by 4. 4 times x divided by 4 equals 4 times minus 16. The 4's cancel here. 4 divided by 4 is 1, so you end up with 1x. That's what we want. Equals 4 times minus 16. Well, 4 times 16 on your calculator would be 64. But it's a positive times a negative is a negative. Minus 64. Okay? Number 5. 5a equals 625. How can I get 1a? What do? You divide by 5. 5 divided by 5 is 1. So you divide this side by 5. Divided by 5. In a way, you took this 5 and moved it to the other side, but since it's multiplying here, it becomes dividing over there. A is equal to 125. Okay? Okay, these are all pretty much the same. Okay, do you think you got the hang of it? You could keep working on those. I'm going to see, does it get any harder? No, they're all pretty much the same. I guess we'll do two more, and then you can do those on your own. And then I'm going to go to the, let's see. Oh, they got a lot more. Okay, we're not going to spend a lot of time on these. These are all very simple. And since this is a rather long lesson, we're going to we're going to jump to the problems on the bottom now. You could work these on the top and check your answers in the answering thing. If you still have questions, you can always contact me for those questions, okay? So we're going to jump to the bottom here and work on some word problems. Okay. Questions 29 and 30 refer to the following table. April timesheet summary, hours worked per week. So you've got Kayla Sachs. It's got 3 of the weeks, but it's missing week 4. And Aaron Grady is missing week 1. We may have to find those. Okay, let's read question number 29 then. Again, you should be pausing and trying these on your own and then checking with me for the answers. Kayla and Aaron worked a total of 77 hours during week 1. So both of them have to add up to 77. Oh, I'm sorry. Week 1, they add up to 77. Let X be Aaron's hours for week 1. There's X, Aaron's hours. Which of the following equations could be used to solve for Aaron's hours during week 1? Well, if this is X, right? What did they tell us? A total of 77 they worked. So what does that mean? Okay, that means, let me do this. Actually, I can use the bottom here. I have some room. I know that Kayla's is 36 plus Aaron's is X equals how much did they work that week together? 77. So that'll help us find the answer. Kayla's plus Aaron's is 77. Is that there? How about this one? 36 plus X equals 77. This is almost the same. Is this equivalent? Is this the same as this? Yes. When you're adding, it doesn't matter which one comes first. If you're subtracting, it matters. But when you're adding, it does not matter. Now, they could have written it like this. They could have written it like this. The 77 is how much they work together. And you take away Kayla's, then you end up with Aaron's. They could have done this, but they did this one. So that was the right answer. C was the right answer. Try number 30. Aaron, okay, I hope you paused it and tried it. Aaron worked twice as many hours as Kayla did during week 4. Let Y be Kayla's hours for week 4. Which of the following equations could be used to solve for Kayla's hours during week 4? Okay, Kayla's Y. And Aaron worked twice as many hours as Kayla did. Well, we know Aaron's on week 4 is 38. Right? So that's Aaron's is 38. And it says Aaron worked twice as many as Kayla. And Kayla's Y.